So, friends, welcome to this lecture series of geomorphology, and in this class we will continue with this river system. So, if you remember in the last class we are talking something about this stream ordering, the drainage density, stream competency, stream capacity. So, we found that mostly when we talk about this sediment load in the system, river system, we do not consider this solution load because it is in dissolved conditions, and the bed load, once we say, it is difficult to measure the bed load accurately. So, that we assume it to certain extent, and suspended load is the most promising load through which we can calculate different parameters of the channel. So, today we will continue about this river system again, and how the river transports, how the system deloads from one place to another, and what are these geomorphological features, erosional and depositional features they create and modify within this reverse journey from head to mouth. So, if you see here the reverse journey, rivers usually begin in mountainous terrains, but not always. For example, we take about the Himalayan rivers. Mostly I am talking about mostly 99% of these rivers, they generate or they originate from this mountainous terrains, but there are some rivers which generate below the mountains. There are plain fed rivers. For example, in the Himalayan terrains, if you go in some of these rivers or the major rivers like the Ganga, Yamuna, the Brahmaputra, the Ghagra, the Kosis, they are originated from this mountainous terrain. So, they are called the mountain fed rivers, and some of these rivers they are generating from these piedmonts. So, and some of these rivers they are generating from the flood plains. So, they are the plain fed rivers, the foothill fed rivers. So, that means not necessarily whenever we talk about this river system, not necessarily always that rivers are all generating or they originating from these mountains. So, depending upon their position, either it is foothill fed, that is coming from the piedmont by this recharge from this groundwater, they are the plain fed rivers, they are coming out from the plains. So, they are these groundwater fed rivers. So, that means depending upon these conditions, the rivers can be defined, either it is a mountain fed river or the foothill fed river or the plain fed rivers like this, but mostly the rivers they generate from these mountainous terrains. They flow downhill on flat plain and into the sea. So, they erode, transport and deposit. So, that means the rivers is starting, this is the source, and it is some source to, it is the mouth of a river. From source to mouth it transports the sediments, it erodes. This region is mostly, it is erosional region characterized by erosion, and in between there will be transportation and there will be deposition there. So, here during this reverse journey from this origin or this from head to mouth, like this human life cycle, it moves through youth stage, mature stage and old stage. So, if you see these figures here, in this youthful stage you are getting very narrow valley, and gradually the valley width increased, and finally the valley width again increased. So, similarly, in the human life cycle also, during growth we have different modifications in these systems. Similarly, both mental modification, physical modifications like that. Similarly, this reverse journey from this youth stage through mature stage to old stage, there will be modification in channel morphology, there will be modification in the amount of water, the sediment, amount of sediment, similarly the style of transportation. So, that means each and every aspect of a channel that is modified from youth stage through mature stage to old stage, and that is why these geomorphic features, either it is depositional or it is erosional. So, characteristics geomorphic features are there which is confined in a particular stage of a river, that is characteristics of a particular stage of a river. Let us discuss it. So, here if we divide this river basins, this side is the youth stage, that means mostly river is carrying out erosion in this area, and here it is mostly the transported and some deposition, and most of the deposition that takes place at the river mouth in form of deltas. And the youth stage, the river carries small amount of water, but it travel very quickly down to the steep mountainous slopes. Most of its energy is used to erode the landscape, and this erosion is occur in 4 ways. What are these 4 ways? One is the hydraulic action. Hydraulic action means it is the water only responsible, nothing else, only water. The force of moving water erodes away the banks and beds of these rivers. So, it is highly forceful channels, water is flowing forcefully, because it is confined in narrow valleys, mostly in this upper reaches, there are mountainous regions, youth stage, they are confined in narrow valleys, and narrow valleys, as it is confined, its force is very high. So, this due to this water's own force, it erodes away the banks and the river beds. So, that is called hydraulic action. So, once water is added with sediment, so here this system is called abrasion. Abrasion means small stones carried by the river erode away at these banks and bed of this river. So, that means if water is only associated with erosion, that is called hydraulic action. If water as well as some sediment particle is added, it is called abrasion. So, if you remember when we are talking about this coastal plain geomorphology and the initial time notch, during notch formation, the initial stage the rate of erosion will be less, because water will be associated, only water is associated. But with increasing of time, when the sand particle is added to that, so the rate of erosion is increases, because the sand as well as water both are responsible for eroding these coastal cliffs. Similarly, here the hydraulic action, that means only water is associated, but abrasion once we say, then with water we are adding sediment and we are increasing the erosion capacity of a river. Then another is type of, it is called attrition. Attrition means here during transportation the particles they collide with themselves. So, that means one particle is colliding with the other, then others, that means here there is a tussle between the particles among themselves. So, as a result the angularity of particles decreases, the roundness it increases. So, that means here they hit of each other, and finally, we are getting these rounded particles, rounded clasts. So, this rounded clast is products of attrition. Then another type of erosion, it is called solution, that means those rocks which are very sensitive to water solution minerals. So, that means those minerals they become soluble in water and it is transported through solution. And as we know, the solution load it does not affect this hydraulic geometry of the system. However, this amount of sediment which is suspended and it is the bed load, they affect this hydraulic geometry and the channel shape of this river. So, that means though we have hydraulic action, abrasion, attrition and solution, but here when we talk about this river erosion only, this sediment transported by saltation and bed load, they are more important. Landforms in youth stage. The river course is confined in the mountainous regions or mountain range. Erosion by this river create particular features or landforms characteristics of corresponding river action at different stages and modify the landscapes on the earth surface. 3 features created in the youth stage. First is the V-shaped valley, then interlocking spurs, then waterfalls. These are the 3 characteristics erosional features, erosional landscapes in the youth stage. So, what is V-shaped valley? Here if you see this valley, it is of V shape, looking V shape, and this width of the valley gradually decreasing and finally it is 0. So, here this V shaped valley, that means it gets their name from this shape of English letter V. The river erodes the landscape and creates a valley in the shape of this V shape. This occurs because of vertical erosion. this river cuts down its river bed, making it deeper. It creates a narrow deep valley. Mechanical weathering and mass movement creates V shaped. This is very important to understand here. Mostly at this V shaped valley, this erosion is downward. So, that means the deeper erosion, the river bed erosion will be there. So, now you see, suppose we are creating a river bed erosion is like that. So, this part and this part, it will be mechanically unstable or geologically unstable. So, finally, there will be mass movement. If you remember, when we are talking about this mass movement, mass transportation. So, here there will be mass movement and there will be fall, topple or many other whatever this mass movement methods are there. So, due to that, so valley widens take place. So, finally, you will getting a wider valley and it is V shape will be here. So, here is this vertical erosion at the youth stage and this part of this rock mass, it is finally moves down, it is mass movement due to mass wasting, and finally, we are getting a V shaped valley. But V shaped valley of the river that can often modify by glaciers at the upper reaches. So, the V shaped valley will be modified by the glacier movement and will create it to U shaped valleys. As we know, U shaped valley is a glacial product and at the upper reaches generally at frigid regions or at the upper ridge mountain regions in the Himalayas and Alps and other areas. The V shaped valley is created by these channels, it is often occupied by these glaciers and once glacier move through this valley, it widens it, its shape changes. So, that is modify this V shaped valley to U shaped valleys. Then another feature of erosion, it is the interlocking spurs. Interlocking spurs, if you see here, one spur, another spur, third spur, fourth spur, that means they are interlocking. So, once they interlock, for example, here also they are interlocking spurs. So, once they interlock, we are getting a river channel which is zigzag pattern. So, that means as the river flow, it meets areas of hard rock, it cannot erode these. So, it flows around them. This creates a zigzag river course. So, interlocking spur is a product of youth stage of river erosion. Then waterfall. Waterfall are formed when the river flow in areas of hard and soft rocks. For example, if you see here, suppose we have hard rock and we have soft rock in below. So, here suppose there is a fracture. Through this fracture there will be erosion and finally, as it is resistant more, it will remain as it is and this lower part, it is soft rock, they get eroded and finally, there will be free fall of water from here to here and creates waterfall. And here this is called plunge pool. This is a temporary pool is generated, this is called plunge pool. And these are some of these photographs of the waterfall worldwide. So, now let us end the youth stage. Somewhere the youth stage has to be ended because we are waiting for this mature stage. So, that means when there is a drastic change in slope, the youth stage of river ends. So, mostly here the features that is called alluvial fens, there is mega fens, alluvial fens. If you see the Ganga mega fen, Gandak mega fen, Kosi mega fen, Satluj mega fens. So, these mega fens or this alluvial, mostly these are alluvial fens. So, alluvial fens, they are formed at this slope break due to change in hydraulic geometry of these channels and mostly it is the slope break which is responsible to change the hydraulic geometry of this channel. So, rivers which were confined earlier in narrow valleys were very forcefully transporting or eroding this river valley and these surrounding areas and they are transporting the sediments within a confined narrow channel. So, once they reach at the slope break at the plain land, so they open up and this kinetic energy decreases. So, that is why what happens, they are not able to transport this amount of sediments they carry and finally, these sediments are deposited there and they create alluvial fans. So, the alluvial fans, if they are coalescence with each other, they join this one alluvial fan is joining to the adjacent alluvial fan and forming a particular type of topography, it is geologically or geomorphologically it is called Bajada. Bajada means it is the coalescence of more than one alluvial, more than two or more than one alluvial fan. So, that means it is here one alluvial fan, it is joining with another alluvial fan, it is joining with another alluvial fan, it is joining with. So, this is Bajada, that means it is coalescence of alluvial fans there. Then comes to the mature stage. The mature stage, during the youthful stage, the river mainly engaged in eroding the landscapes. Erosion breaks of particles of the rock and soil from this bed and these banks of the river. They are carried along this river and are known as the load. So, that means it is total load, suspended load, bed load, so dissolved load. So, this total load of this sediment, total amount of this material is carried out by the sediment, it is called load. So, the load is carried from upland to downland area. The process is called river transportation. A river can carry large amount of rocks, sand and other dissolved minerals too. So, depending upon that, this terminology is used, either it is a bed load, it is a suspended load, it is a solution load, like that. So, rivers that are subject to large fluctuation of discharge or that drain poorly vegetated regions or that have generally large loads tend to have high percentage of solid load and are likely to have braided channel. So, that means depending upon the load of a river, what type of channel morphology will be there. If you remember, when we are talking about the channel morphology, either it will be a straight channel, it will be a meandering channel, it will be a braided channel. So, we are talking about the amount of load as well as the nature of the load, either it is suspended sediment is there or it is bed load sediment is there. So, depending upon that, so it is a either it is a braided channel or it is a meandering channel or it is a straight channel. So, other it is an anastomosing channel, that will depends upon the load and the slope of the system. Rivers that drain heavily forested regions or overflow from lakes that act as settling basins or drain karst regions tend to have mostly dissolved loads and are likely to meander. Because if you remember, when we were talking about this experiment carried out by Sam and Khan 1972 or 71, they were not able to create a meandering stream until unless 3% kaolinite clay was added to the system. So, that means if we do not have this suspended load, we are not able to create meandering channels. So, that means those channels which are coming out from the karst regions or coming out from catchment area from clay. So, that means their suspended load is more as compared to the bed load. So, those channels will tend to take this meandering channels rather than these braided channels. So, these loads irrespective of their origin, so they are transported. So, this transportation are 4 types. One is rolling type or it is called traction mode of transport. Then second is saltation mode of transport, that is bouncing, that means jumping like that, and third is suspension and fourth is solution. But this solution load, it hardly affect or it does not affect to the hydraulic geometry of this river and this channel shape. Here the traction mode of transportation, here if you see these boulders, they are moving with close to bed, that means on the bed they are rolling. So, the large rocks they are rolled along the bed of this river, that is called traction. Then saltation, if you see here, it is jumping, and similarly there will be another jump, there will be another jump. So, this type of jumping, that is called saltation, that is bouncing. The smaller particles or the smaller pebbles, they are bounced along this bed of this river. Sometimes they are picked up by water and sometimes they remain contact with the bed. So, these are these contact points. So, they are moving like jumping. So, this is called bouncing back or this is called this saltation mode of transportation. Then the third one, it is the suspension. Suspension means if you see, you always remain in the water, they do not touch the bed of a river. So, that is suspended particles. So, mostly the smaller particles, the clay size particles, they are transported through the river in the suspended mode. So, here light material like sand and silt are floating in this river. So, the fourth mode is the solution mode, that means these soluble materials they remain in solution and they are transported. But here this most important thing is that the solution transportation or the solution mode of transportation, it does not affect the hydraulic geometry of the river, it does not affect the channel shape, it does not affect this habit of this channel, like either it will be a meandering channel or it will be a braided channel, it will be a straight channel, it will not affect. Okay. So, these other types of transportation, there is a bed load, the saltation load, the suspension mode, these three that affect this channel hydraulic geometry. Then landforms in the mature stage. In the mature stage, the river begins to slow down, and so it begins to deposit some of its load. It creates the following geomorphological features. First is wide river valley, then meanders, then floodplains. If you see here, this wider river valley, in the mature stage the river moves from side to side and the valley becomes wide and flat. So, it is the floodplains. So, that means it is frequently change in river course within the floodplains that occur. If you go to this, if you see this satellite imagery of a river Ganga or any river, particularly this plain rivers, plain areas which are rivers flowing through plain areas, particularly in Bihar and eastern UP, you will find number of channels, paleo channels there within the floodplains. So, that means rivers change their course frequently within the floodplains. Weathering and mass movement continues to wear away of these sides of this valley, and that is why the river valley widens, wider river valleys are get in the mature stage. Here if you see here, this is the river valley, the width of a river valley, but actually the river is confined here. So, during flooding the river may pass through here, it may pass through here, it may pass through here. So, that means any part of this floodplain, the river valley, within that river valley, the river may migrate. So, multiple channels are there. That is why during rainy time you will find only one channel of this much width, but during summer time you will find number of channels are there. Then landforms in the mature stage, another is the meander. The meanders, if you see here, gradually the curvature changes, and finally this part of this river, if this is the transport direction, this part of this valley it is getting eroded and this part it is deposited. So, similarly with time this river takes this shape. If you see here, original river was of this much, this was this travel, this is the path of this original river. With time this curvature changes, and now the curvature is changed of this part of this slide, and with geological future you will find this will be moved like this, and finally this part will join together and this will cut off, and this is called meandering, river meandering. This is called oxbow lake, and this that is why it is called oxbow lake. It looks like this oxbow, and here if you see, this is the system, and with time this will increase and this will increase, again gradually increase, and finally they will join here and the river will follow this path and this part will be abandoned. And in the meandering channels and the meanders, there is a particular type of flow that we encounter, that is called helical flow. Helical flow means, if you see here, these velocity contours of these channels at the three different parts, this is A to A dash, that means the straight course. Now, here B to, it is one meander is here, another meander is here. Here you see the velocity contours, that is low velocity and a high velocity at the center, and these velocity contours they are uniformly distributed, symmetrical. But here if you see, this is asymmetrical. So, that means B to B dash, here we are getting high velocity in these regions and here we are getting low velocity. So, that is why this velocity contours, if you see this distribution of this contours, the arrangement of this contour, that is asymmetrical arrangement is there. Similarly, in the other part here if you see, this is also an asymmetrical arrangement and the maximum velocity is this side and the minimum velocity is this side. So, that means if it is straight course of river, the velocity distribution will be uniform and symmetrical through the channel width. But if it meanders, there is a particular type of flow that is called helical flow. Helical flow is mostly responsible for this weathering and the erosion of this river bank at these meanders. And these are some of these photographs of the meanders, and this is, if you see, this is an oxbow lake. So, that means it is an abandoned meander. So, similarly here you are getting an oxbow lake. Oxbow lake means it is a abandoned meander. That means earlier the river was flowing in this way, and later due to this change in hydraulic geometry, then finally this part was cut off and this formed an oxbow lake. And landforms in the mature stage, another is the floodplain, and here this is the width of this floodplain as we have discussed earlier also. So, within the floodplain there are frequent movement of these rivers from one part to another, and finally, the gradually if you move or if you confine yourself within this rivers, you will find mostly it is coarse grained particles, and away from then fine grained particles are there. So, as far soil development is considered, these floodplains they are very good for soil development, mostly it is away from the rivers, and due to differential compactions, these rivers or these floodplains after soil development they are compacted and becomes, and this rivers becomes elevated topography to certain extent. Then at the old stage of this river, nothing to do, only the distribute water, whatever this water is carried out by the river, it is distributed through the distributaries and forms the delta. So, in the old stage the river is carrying lots of sand and silt, it is now flowing over flat land, and so it is moving slowly. Therefore, it begins to drop its load, it is called deposition. Like erosion in the youthful stage, deposition also create many features of landform, that is depositional feature, and the most promising depositional features in the old stage of the river is the river delta. We have different deltas and levees, and deltas are mostly for hydrocarbon potential mostly studied, and natural levees if you see here, natural levees if you see with this river and both side of river we have elevated topographies. So, that means this topography will be look like this. So, that is natural levees, that means during over flooding. So, here these coarse grained sediments, mostly this sand, their fine to medium sand or coarse sands they are deposited here, coarse sand are deposited, and gradually the grain size decreases. So, once the grain size decreases, with time you are creating a topography like this and a topography like this, and in between the river is flowing, this is the river bed. So, this elevated topographies due to deposition, that is called levees, natural levees. And here you see this is a block diagram, here these coarser materials are here, coarser material is here, and gradually the coarseness decreasing and becomes more finer and finer. So, here we can get differential compaction effect, and as this is mostly it is sand, it hardly undergoes any differential compaction. So, that is why this topography gradually decreases here and decreases here and becomes elevated here, elevated here. So, this is called natural levees. And the deltas, it is the most promising feature in the old stage. There are many deltas in the east coast of India as compared to the west coast, that it is the interaction between this river as well as a marine system. So, I think we should stop here. This is the all about this fluvial geomorphology, and we will start with a new topic, mostly it is glacial geomorphology in the next class, and thank you.